All right, so let's talk about why we use CMS. So one of the important reasons why we wanted to use CMS was to really create a self-serve environment, right? So David touched on that point a little bit, that we wanted to reduce the cost and the time invested of our developers correctly, right? So we want to allow our business to be self-service and self-manageable, right? So if someone wants to change the title on a page, change some text, you should not get a developer involved in such changes. It doesn't make sense, right? There are better, I think developers should solve engineering problems and not do stuff like that. So it's really important that your CMS allows you to create an effective environment that basically helps you be as self-service as possible. Again, I don't think it can be 100% self-service, but we can try and go in that direction and see where we go with it, right? So that was the essence of that. We also use workflows. I agree with David that workflows are dissipating. A lot of the times they actually slow down the process, right? But then I think workflows allow ensuring proper process for a lot of critical content, right? You don't want one person to roll out legal content that can have legal consequences, right? You don't want to allow any one person to roll out changes that can impact conversion negatively, right? So there are some gotchas, there are some really critical pages for which you do need it, and there's no real way getting around it. Emails work, but then there are always, it's not really foolproof. They can get ignored, right? So we use it for workflows as well. We wanted to build a system where we can tightly control standards, or again, try the best we could, right? So when we talk about standards, they are SEO standards. So if we are hosting templates, we are driving the delivery through the CMS, we want to make sure that people are not doing anything too funky. We're sort of sticking with the Fed standards, the front-end standards, right? We also wanted to make sure that we use SEO best practices and we can reuse that aspect across the pages. SEO is really critical. We want to make sure any page that we roll out has all the SEO best practices. It helps us enforce that, right? So that's the area we think CMS systems really shine up and sort of have that governance around it. Reusability is a big piece of it. So let's say someone wrote a testimonial for our company, right? So the same testimonial will get displayed across the site at a lot of places. So we want to be able to create just one asset and use it throughout the site, right? And besides content reusability, there is also a feature reusability part. So what that means is, let's say there's a new personalization service that comes up, right? So we want to let all the stacks within our company or all clients to basically leverage that service, right? So they have an option to either go integrate themselves, personalized, or we integrate in CMS and let those guys call CMS, and we've done all the hard work and the heavy lifting of it, right? So that is really important because I think that helps a lot with the adoption in the company, right? Fallbacks. We use CMS pretty heavily in the company, and a lot of the times we see that the changes are chaotic and bad changes can roll out, right? So CMS storing all the version history gives you a chance to just flip it back, roll it out, right? So you've got to be able to do that quickly without impacting business too much. And this is the right environment for collaborating in terms of localization and personalization. Both of them are really critical for our company. So we support around 8-9 geos. So our translation experts, they need to have an environment where they can go either manually translate it or export it out, translate it, import it back in, right? So seems the right fit to do that. Again, personalization. So we integrate with a lot of services in our ecosystem to promote usability. So what we want to make sure is that CMS provides an effective way for someone who's non-technical to come in and define experiences. So when I say experiences, it's the variant model, right? So if a user has bought DNA kit, we want to show something else, right? We don't want to promote DNA kit to that. So defining these experiences is really critical, so it should be really intuitive, and that's what we really want to do as well. Slide is pretty standard. What do we store in it? We store structured content, we store binary data, images, videos, PDFs, bunch of presentation related stuff, the styles, the scripts, and the template. All right, so what was most important for us before we started revisiting our architecture, right? Performance, definitely. We know nobody likes browsing slow pages, and we wanted to build a solution that was really optimized, and we wanted to make sure that a lot of that aspect is in our control, and we don't have to rely on a lot of the downstream stacks to basically control that. We'll see how we were able to get there. Performance is really important for conversion and retention both, right? So if you're shown a sign-up page and the sign-up page takes 6 seconds to load, you're going to bounce out, right? You're going to basically, people have like multiple tabs open. All it takes is a second for a user to get distracted. You're gone, right? So you lost, basically a user got passed out. So it's really important for that, and it has a role in retention as well. So slow users, I'm going to cancel my subscription, right? So this was one of our foundation building block. We knew we had to build a system that's highly performant and also available. So I think a lot of the companies have similar requirements on availability, the 4 nines. So what that means is the system will be offline, or there cannot be an outage, an annual outage of more than 50 minutes. That's tough to achieve. And a lot of the times that's out of your hand, because if you're relying on a core product heavily, if there are some issues in the core product, again, it's out of your hand, right? There is some database deadlock happening, you can't control it. And we saw this problem earlier, that our availability was not as great and things were not really in our control to fix it, right? So we wanted to break free from that cycle as well. Any compromise on availability we know leads to revenue loss. Unhappy customers, they definitely don't want to see Ancestry.com and a 404 page, they don't want that. And the company reputation is at stake. I don't think even for rolling code, anyone brings down their site anymore, so it's just like 24/7 available all the time. We also had a strong requirement around scaling our system. So typically business have very seasonal traffic patterns, right? So Christmas time, we know that everybody gets a lot of traffic. So scaling the system up should be really effortless, right? So you should be able to quickly scale up, quickly scale down without getting too complicated with or getting too invested heavily into doing that, without spending too much developer time and effort on it. We also know that we have seasonal promotions and campaigns that can drive that traffic pattern. So all I'm trying to say is the system should be highly scalable and it should be effortless to scale. And it's really important for the success of a growing business. It's really critical. So you can't go to higher management and say, this is the best the system can do. I can't do anything more than that. So it's totally not acceptable. So it should be horizontally scalable. So given these were the core problems that we were solving, what were the options that we had, right? So we really had these two options at hand. So we either go with a monolithic approach, use everything out of the box as a complete solution, or we say, okay, guys, let's use CMS for some core features. Let's build the rest of them on our own, right? So we'll talk about the pros and cons about each of them. So again, pointing one of the things David said, if you go with a solution that's monolithic, you're doing a lot of stuff that is product specific, right? And if your CMS implementation is huge, if it is hosting a lot of content, that can be actually a big problem in case the product does not scale, right? And product roadmaps can change. It's not in your control. It might work out in your favor. It might not work out in your favor. So I think it's in the best. It's actually in the best interest for the company to basically future-proof it, right? So I'm going to safeguard my systems and use the best of what the product offers, really. And this also has a problem that people might live with some of the problems which are not as severe, right? So if you have a CMS solution that's monolithic, and let's say the authoring is slow, so you might tend to live with it just because the cost involved in overhaul is like so big. It's going to scare anybody, right? So that's why I think we have learned from our mistakes. Let's not go there anymore. And so what we decided is, okay, so one thing I have to clearly say here is this does not mean that Magnolia is not good at doing these things. We just chose to go a different way and use CMS as a content store, as a content service. So we said, let's use the core content as a service features of Magnolia, which is we are going to use it as a content store where the content actually gets stored. We are going to use a versioning feature so that we can roll back. We have fault tolerance. Searchability, activations, you can do schedule activations, manual activations, the workflows for orchestrating business processes, the WYSIWYG editors for doing small changes, and also the digital asset manager for doing like transcoding and stuff like that. And we said we are going to build the rest of it on our own. So let's see how we designed our architecture, based on these principles. So this is how our architecture looks like. So we have a high availability layer as the first entry point for all the traffic. So this layer takes care of all the rewrites and the redirects. It also caches data. So that's really important because this offers our first fault tolerant layer, right? So if all the downstream systems fail, whatever reason, it's network outage or whatever, we show users something back rather than showing a 404 error page back. So this layer usually is made using a module like Apache HDBD integrated with a caching module, or you can use something like Nginx to implement this. So this is like our first level of fail-safe rendering. So the rendering layer or the custom application that we have built basically takes care of page rendering. This is the guy that's actually doing the heavy lifting of calling content, merging the template, and sending the page response back. It also takes care of personalization. So if there is a user profile service based on which we want to personalize some of our experiences, what we'll do is we integrate with the new user profile service at that level, right? It enforces content lifecycle. A lot of our traffic is basically a lot of our pages are basically lifecycle based, right? So if we are rolling out a Christmas campaign page, we know it needs to come down 26th of December, right? So this is the layer that basically enforces that content lifecycle. And so we'll define the lifecycle in the CMS layer. We'll say this page should go offline on 26th of December. But the rendering takes care of the business logic of seeing whether I should serve back content or not. So all the business logic, application logic resides at that layer. Of course, it has caching, and that's the real strength, right? So you're building your own rendering platform. You're free to choose whatever caching infrastructure works best for you, best for your business needs, right? Redis, Memcache, whatever you want to choose. So that's the real advantage that we got out of it. So the rendering layer also talks to cache for content. And again, so our vision for CMS is actually as a true content store, nothing more than that. That's the strategy that we use. And once we get a page request, cache layer is, all it's going to do is it's basically going to give you content back as JSON data, basically. A RESTful API is all it did. Just going to quickly cover fault tolerant here. So we have built tolerance at the rendering layer as well. So a simple case would be, again, you're building your application ground up. You know what your requirements are. You know what systems fail in your ecosystem. So you want to build fault tolerance for those things, right? So if on a page, you're calling a service to generate the header, if the header service is down, your page should not fail, right? You show the rest of the page without the header. So that's where most of our business logic that ensures tolerance for failures have been wired up in. Again, if you go with a monolithic approach, I'm not saying you cannot do that. I think at times you can do that, but it can require a lot more effort getting that done. So that talks about both the cases. If the cache that we use is failed, we call the CMS system so that responses are slower, but then the pages still work. If a dependency fails, just don't show that, show everything else. All right, so let's talk about the cache layer. And Magnolia sits right underneath it. The reason we added a cache layer was to basically abstract the underlying CMS system, right? So all the upstream stacks do not need to know what CMS system we are really using, right? So that's actually making us future-proof. So tomorrow, let's say there's another CMS we want to use, none of the upstream stacks would need code changes to actually incorporate that. So the cache layer actually, the cache layer is just going to serve content backup. It has no contextual information where that data is going to get used. Like in our case, we know that we're rendering web pages, so our application is going to probably merge it with a template, embed some styles, send it back up. But then the same data can be leveraged across mobile platforms. If you have a mobile app that needs data, you can leverage that. So that's the benefit. It's just going to surface back content. Again, when we talk about CMS system, I think the vision that we have at the company right now is it should not do anything more than managing content, right? And I think that's where the real difference is. And it's going to provide a consistent RESTful interface for all upstream stacks so that none of the upstream stack needs changing ever again. Hopefully our interface is designed like that, it doesn't need any change. All right, so this is the benefit that I was talking about. So if we have a consistent RESTful interface, we know that we can use the same data across multiple channels. If it is email campaign, if it is our our mobile app, if it is our custom rendering layer. So this is a sample example of how we send data back, right? So it's basically key value pair, and that's all it does, just content. Guys, feel free to stop me in case you have any questions. Let's keep it a little more communicative. All right. So what is the other benefit that we got by going down this road, right? So we realized that scaling the system is not as expensive anymore. We reduced our overhead on scaling of the system. So you can see, so this data is based on rough figures. We have tried to scale our system up. So let's say our traffic increases 5 times. What we need to do is we basically would be scaling our proxy layer 2 times. We need to scale our rendering the most because that's the guy that's doing most of the heavy lifting, right? That's what we need most amount of scaling. And then all the other would not actually need scaling to the same level, right? So I think that's a big win right there as well. All right, so this is just a quick recap about the pros and cons. I think this model is more simplistic for me. I think we have actually, I think this distills the content management system down to its very essence, right? And it also encourages structured content. No more you're going to say store blobs because you know this data has more value across multiple channels now. So you'll be much more careful designing your data model and try and make it like a little more structured now. Using this approach, we got like the performance and the fault tolerance in our own hands, right? Unless relying heavily on a vendor basically for those things. So using bare minimum CMS components also helps us because there is now like a very low cost of replacing the CMS in case there is ever a need that arises like that, right? So again, these are all lessons we have learned from our past, how expensive it has been for us to replace CMSs. We don't want to get there again. So we want to really abstract everything we can and use the bare minimum components. So now, if you talk about the bare minimum components, if a CMS solution has like 50 things to offer, you're using 5 of them, you've actually reduced your overhead for applying patches and doing upgrades, right? So you know that once you upgrade your system, you're just going to test authoring, workflow, a bunch of other stuff. So that would actually reduce, again, this is again going to save a lot of developer time, QA time, and increase the cost saving actually. So that's definitely a benefit. And we also spoke about the multi-channel benefits and the scaling the solution would not cost as much. So let's talk about some downsides now. So we all saw that we built a lot of our components on our own. That's definitely some more initial overhead. And you should be sure you're signing up for that because at times, based on your solution, that can be a major thing. So you should know you have the right people to execute this and the right funding, the right amount of time to deliver something because we definitely don't want to rush such a thing because again, that can cause chaos and a lot of rework, right? So definitely know that there'll be some upfront overhead in that. And of course, we miss out on some nifty drag and drop page editing features. Now that we are rendering the content outside of the CMS context, you can't drag and drop widgets and you basically lose that. So I think it was a calculated decision that we made at our company that, okay, I think the pros are working out much more in our favor versus pleasing our marketing team who can do more WYSIWYG editing, and that's why we went in that direction. And let's talk about some numbers now. And I'll hand it over to Virdi after that. So this is how we roll right now. We have over 20 releases happening every day. Each release has about 10-15 pages, so they're pretty big releases that happen. The total number of content assets that we are storing in the system right now is 15,000 and it's rapidly growing. The total number of pages that active pages that we are rendering out of our entire ecosystem is about 1,000. And again, these are active pages. There are other pages that have been archived and they're just sitting there, right? And we localize across 8 or 9 geos. We don't localize all the pages, but this is just to give some context as to how much data we're actually dealing with. We serve around 21 million requests per day using single-digit VMs. I think that says how efficient the rendering is, and they're not like beefy machines. It's like 2 core, 2 clock machines. That's it, right? That's the big win now. So our average page response is 60 milliseconds, and it is consistently 60 milliseconds. That's what we really wanted, right? Our uptime, since we have built that multiple layers of fault tolerance, has gone up. I think we can round it up to 99.99, but I think we are pretty close up there. So again, these 2 things were like really, really important for our business, and I think we got there using the architecture that we decided works right for us. All right, so I think we have some time for questions. Oh, wait, sorry.
The stack that you described, is that used for both your logged out marketing pages as well as your logged in like interaction with the app?
It is actually.
They're the same?
They're the same.
Okay. And piggybacking on that, do your users upload like user-generated content, like family photos and stuff like that?
So we don't store any user-generated content in the CMS right now. I think we have other systems that are managing that, so we did not really explore that aspect of the CMS yet. So.
I was interested to know if you do anything special to optimize the images that users upload and serve that, because I know they could upload like a massive image file, and that would affect page performance.
So I think any images that we are loading in the CMS right now, they are all served via the CDN, right? So we have some optimization there. And I remember that to ensure that people don't screw around with the page too much by uploading big images, we had put some checks in place. Like if you're going to upload like a 1 megabyte image on a page, it's totally unnecessary. It's going to slow down the page. You shouldn't do that. So we had created some workflow steps to basically block the user that you're going to slow down the page. Are you sure you want to do that? So we tried doing some of those things, but like we didn't get like heavily invested in that. Yes. All right. Who else?
You mentioned URL management as one of the modules, so I was wondering at what level you do that and what that actually kind of means.
You want to talk about that?
Yeah, so for these legacy sites, it's pretty much just a flat structure. Every single node that is able to create a page, it doesn't really create a URL, a customizable URL structure, but for our site that we're still migrating, that one is able to take advantage of Magnolia's node-based structure to create URLs. Unfortunately, we can't demo that right now.
How do you handle like redirects of legacy stuff? Do you have a good way of managing like 301 redirects and that kind of stuff?
So we are still managing the initial redirects at the top layer because we don't even want that traffic to hit our downstream servers.
Yeah.
So it's all Nginx or Apache sort of a thing that does that. And URL management, again, I think we store the URL structure as content in the CMS, but it has meaning outside of the CMS in the rendering layer. So that's how the mapping happens. So we do make URLs configurable in the ACOM site, but the configuration is stored in CMS so that, again, you have some UI to manage that, right?
With the amount of layers in which you're caching, do you have any special like automation to like invalidate caches on deploy or anything like that?
Actually, we should talk about that. How do we pre-populate our cache? And
yeah, so we were able to use Magnolia's observation module to basically say anytime that some piece of content is edited, we'll throw a message into a queue in our gateway, or that's what we call a rendering stack. We'll pick up that message and then invalidate cache. Okay. So it all happens on the fly. We don't have to touch anything.
And so one great thing is whenever a save event happens that's supposed to flush a cache, we actually send the updated data as well along with it, so that it's not that when you get a hit, it doesn't find it in the cache called CMS. It's that cache always has the latest data. So we are like pre-populating that data already, so that we don't even want like that one request to slow down.
Right.
So, yeah,
right.
It's pretty much aggressive cache loading.
Aggressive.
Do you do that through commands or workflows or something, or?
No, I mean it's so a little bit on the background side of things. So Magnolia is going to push this updated message into RabbitMQ, and then our gateway stack is just listening to those messages. So there's no workflow or anything.
Okay.
I mean, there's workflow around editing the content, but as far as those updates go, it's all automated.
Interesting.
Cool.
One final question.
Sure.
One I had. So it's obvious as you were doing your presentation that this at least a second or third iteration of content management. I'm wondering if you could tell us a little bit about what was unsuccessful, even if it's not the vendor,
Sure.
and why it was why you left that.
Okay, sure. So I think the first iteration of CMS solution that we had was actually a homegrown solution. And I think our company grew much faster than the speed at which the solution could evolve. So we made a decision that, okay, we got to have much nicer features, like much more version control, much more control in terms of workflow. That's when we said, okay, let's start looking for other products. And I think one of the problems that really, so I think the crux of the main point that I was trying to say relied on those three things: performance, availability, and scalability. I think we have realized by tightly locking in with a vendor, there is a lot of things that is out of your control, and sometimes the products don't scale well, and you don't want it to have like a big impact on your deliverables, on other stuff that's piggybacking on your main module, right? So there'll be other stuff that is backlogged that are waiting for you to finish something. But while you are finishing something, you realize that system doesn't scale. What do? You don't have time to redo this. So I think we just, the intention was to future-proof us on those three aspects, which we had trouble with some of our older implementations really. And it could be a small thing as CMS systems serve fast pages. Most of them use their own caching solutions, and it does give you faster rendering. But maybe they do not do that consistently. Maybe you see spikes once in a while which are unexplainable, which are you can't just justify those things, right? So I think it's small things like that that made us think like, let's go our own way and do it. Cool. Anyone else? David, do you have any thoughts? Comments?
Great.
Okay, awesome. Cool, I think we can wrap this up then. Thanks, guys.